Hello everybody. We're going to go ahead and make a very quick video about a common question I get in regards to Cisco ACI fabrics, and that namely revolves around modular switches and the use of dual or single supervisor setups in the ACI spine. To make this quick, we'll keep going forward without further ado. Let's take a look at a very basic overview. We see on the left we have a 9500 with dual supervisors, and just so that we're clear, these right here are your supervisors. On the right, same 9500, single supervisors. Don't worry about what line cards are in here or the lack of power supplies. That's irrelevant to what we're doing today. Here's what dual supervisors look like in your recommended 3-spine fabric. So just the same thing multiplied 3 times 3. There you go. Here's what single supervisor looks like physically. Same thing times 3. So 1 times 3. Okay. Here is where we come into some common questions and some confusion people seem to have. So let's talk about the failure scenarios that are experienced in an ACI fabric, and let's talk about how ACI handles those types of failures, whether it be in a test domain or that you're testing, or in production if you see a failure and you observe behavior that you might not understand. In this scenario, we'll compare single and dual supervisor behavior at the spine level. So here we go. We're going to start with your 3-spine architecture, and all 3 spines will have dual supervisors in them. So here's loss of an active supervisor, whether it dies on its own or in a test where you pull it. Either way, it's failed. First thing that happens is it fails, and there's watchdog timers in there, and it's instant. It is instantaneous when this happens, right? When that fails, because in a dual supervisor setup in ACI for the spines, the supervisors operate in warm standby mode. Therefore, it requires a reboot. So it reloads the switch so it can bring itself up on that second supervisor. Now, because this is absolutely instant, right? We have ISIS underlay, there's watchdog timers, it alerts the network, and within a second, less than a second actually, traffic from those routed links from your leaves to that spine are automatically removed from the equal cost multi-path forwarding array, right? So no more to this spine do you have connections in the spine leaf, and traffic converges over. We've done some testing internally using a Spirent generator, and it came out to be, what was it, maybe 10 packets and 100,000 that got dropped in the worst case scenario when this happens. So it accounts to less than 1 millisecond of an outage, if you want to call 1 millisecond or less an outage, because there are many things at play in the underlay. ISIS works, and we have a lot of timers in there. Things just happen, and they happen instantaneously. We're talking about routed links in the underlay here. So all this is instantaneous. So you're not going to experience any traffic loss. And that's just how we've designed ACI. That's how it works. So the switch reloads. Then once everything is done, the supervisor becomes active. You may see that the process can take around 10 minutes for the spine to come back into the fabric as a participant in the equal cost multipath links and as a spine. Now there is a reason for this. That 10 minutes, there's a hold down timer that prevents ISIS, which is the underlay protocol we use to disseminate VTEP information. ISIS holds it down because we are waiting for BGP, ISIS, we're waiting for the COOP database to get resynced, we're waiting for all this stuff to be 100% in sync with the 2 remaining guys so that they're all accurate, it has all the information it needs, and then once that hold down timer expires, now you see it come back online, now you see traffic forwarding through it. The reasoning for this is if it came up as soon as that supervisor was active and everything was ready, you have the potential for a black hole, because while things like control plane that's local to it and things on the box itself are up, different protocols first need to converge and get updated, and then the COOP database has to be updated on it, and that's why we hold it down until we're absolutely certain everything is 100%. So technically speaking, it's around 10 minutes that this spine will be off your fabric until it comes back online, right? That's the failure you're going to see here. So that's why that happens. But you literally may not even see 1 millisecond of outage. You might even not even see half a millisecond. You might not see anything at all, depending on your fabric. But for the most part that we've seen, it's less than a millisecond of outage. And that's what dual supervisor scenarios look like. And then you can just RMA the failed supervisor, reinstall it, your network keeps humming. Single supervisor. So same scenario we're going to play out here, but here is what happens with the single supervisor. Same thing that's going to start with a failure of the supervisor, whether it's a genuine hardware failure or you've decided to pull it in a test. Supervisor fails, the switch is down. It's hard down until that supervisor is either reinstalled or if it died, an RMA is replaced. Now the same thing applies as to what happened previously with the dual supervisors. Traffic will instantaneously swing over, right? ACI will then remove the links from all these switches to that now dead spine switch out of the equal cost multipath array. So that's it. Traffic just swings back over because remember, once again, all routed links. So you will see exactly the same thing, less than a millisecond if you see anything at all upon failure. The difference here is that it's down until you place that thing back in, that app supervisor back in, or you replace it because it failed. Okay, therein lies your difference. Now let's take a look at the observations that we've seen, both what I've seen in testing internally and then what we've observed here at a very high level in this very quick demonstration. Let's look at what's the same between dual and single supervisor. We know that they will both experience 0 to 1 millisecond of outage, and I do have an asterisk there, and let me elaborate on that. 99% of the time, this is what you're going to experience, but this can depend on things like your CPU load, memory, and a host of other things of how you're using the spines and whether you're thrashing them with some type of monitoring tool or you're doing other things to them that's causing a lot of CPU thrashing and other issues. But for 99% of the cases I have worked with in my career, you see 0 to 1 millisecond of outage when either a single supervisor goes spine switch goes down, or a dual supervisor when it has to reload to bring up the warm standby. Okay, so that's your mod may vary based on some varying factors and how much abuse you're putting on things like the CPU and the memory on those modular switches. In both cases, the spine is removed from as an ECMP member. In single supervisor, it's removed until you either put the supervisor back in or get the replacement and put it back in. As we're in dual supervisor, the only difference is its spine is removed until the reload is complete, all protocols converge, and the hold down timer releases, and it becomes part of the fabric. No control plane, you will experience 0 control plane outage. Data plane traffic continues to forward with 0 to maybe a millisecond of an outage, if you want to call that an outage. The difference is, single supervisor is less expensive up front. Dual supervisor does have the additional cost of a supervisor. So there is that difference. The biggest difference in my opinion here is that in a single supervisor scenario, a spine switch is down until it's replaced. In a dual supervisor environment, the spine is recovered in a matter of minutes, not days or hours, depending on what type of support contract you chose to purchase for your modular spines in ACI. It's just 10 minutes. It comes back up, you can continue operating. This is going to depend largely on your environment. That being said, there are arguments for the validity of both scenarios. Okay? Both are valid scenarios in deploying an ACI fabric for your spines. Both of these are completely valid. Where I say single supervisor is not valid is for people that elect to only do 2 spines. If you choose to only do 2 spines with a single supervisor, if that supervisor fails, you are half of your infrastructure for the spine, half of those equal cost multipath links are gone, and you are now running on a single spine. And you will wait hours or days, depending on your support level contract, until it comes up. And anything can happen in that time. Something may go wrong, something may not. But if it does, something breaks, something happens, or a mistake is made, and that spine comes offline, you have no fabric now. You are hard down in your data center. Okay? That's where I would say if you're going to go with a 2 modular spine setup instead of 3, then I would say dual supervisor is mandatory in a 2 spine setup. In a three or more spine setup, you get into both valid options here, and it's really going to depend on a lot of different things about your environment. So in conclusion, we know that environments with only 2 spines, dual supervisor should be an absolute must. Environments with 3 or more spines can still benefit from dual supervisors, right? In both scenarios, the traffic converges without any control plane outages, and you still experience 0 to maybe up to 1 millisecond of an outage, once again, if you call it that, right? And with a single soup, you're just waiting until you get the replacement to bring it back online. And with a dual supervisor setup, that switch is out of the fabric for around 10 minutes, and then it's back online. So it really depends on your environment. High performance computing, where you're relying on and you're really beating on those links, and you need and want them all to be running all the time, you might want to go dual supervisor, right? Because you really don't want to have to converge and start to sweat if you are utilizing a lot of those links or a lot of the capacity on the links you have. There might be SLAs tied around it to your customers, to some of your internal business units you're working with, or there might be government regulation that mandates you have a specific set of uptime. With three or more spines all being dual supervisor, you have just added that much more redundancy. And from my experience in the field, the little bit of additional cost for a supervisor, for a dual supervisor setup, in the grand scheme of deploying a brand new fabric, is very minimal. If you were to build a BOM for a full new data center fabric, and then you decide, okay, let me do two supervisors, and then let me take out and just do 1 supervisor, what percentage of the total bill of materials do those additional supervisors add up to? In my scenarios, this is anywhere between maybe 1 to maybe 3%. It is a very, very small cost to pay to have a lot more peace of mind, so that if middle of the night you're getting the page that the switch is hard down, once again, you may have people creating artificial panic in your organization that keeps you up, even though you know that you still have at least 1 spine going in a 2-spine scenario, which for me would still make me sweat because I'm down to 1. So now I'm rolling the dice. But even in 3 or more spines, if there's somebody in your organization, high up, management VP, or anyone else, that creates enough havoc and then generates all this artificial panic, you could very well be up having to monitor it, having to play the traffic cop for nothing, because there might be somebody that holds a little bit more political power or clout in the organization that is not going to accept it being down. Once again, there's a variety of different layer 8 type things, right, that you can deal with. All I'm saying is think about it from an engineering perspective. How much redundancy do you want, and what's the cost of it? And what's the cost of being woken up and staying awake all night for something that's not an issue, especially if you have people that are prone to creating artificial panic. Compare the cost of those additional supervisors to your entire bill of materials cost, and you will find that it is a very, very tiny amount of money percentage-wise, but it removes a lot of headache later on. It buys you peace of mind that the switch will be back up and you'll be running, people will be happy. That's all I have today. I hope this helps you figure out your decision on whether you want to go dual or single supervisor setup in your modular spine ACI deployment. Bear in mind, once again, please take a look at this carefully. You'll understand a little bit why 3 is kind of the magic number, but 2 is acceptable. Just understand the risk of 2 and understand why we recommend in a 2, it should be a must that you do duals. I hope it's been informative for you guys. Stay safe out there, and until next time.